All right, this one is not going to be fun. 5.23. It says a curve of radius 73 meters is banked for a design speed of 85 kilometers per hour. I know earlier I saw somebody had 100 kilometers per hour, so don't worry about the numbers. But so there's banking here. It says it's designed for a speed of 85 kilometers per hour. That means, I'll write down 85 kilometers per hour. That means it's designed for just the normal force to provide the centripetal force, to keep it on the bank. There's no friction. Why this is important is that allows us to figure out what the bank angle is. So one more time, you guys have all seen this a bunch of times. Here's FG. Here's Fn. Without friction, Fn in the x direction is what provides the centripetal force, and Fn in the y is what balances gravity. So if we write out our sum of the forces equations in the y direction, you have Fny equals Fg. Really what that is Fn, now is it sine or cosine? If this is theta, that means this is theta. This is 90 minus theta here. That means this is theta, right there. So Fny is the adjacent side of the triangle over here. So that adjacent side means cosine of theta equals, instead of Fg, I'm just going to put mg. Fn in the x, which we know has to be Fn sine of theta, because it's the opposite side up there, but it's drawn down here, is equal to your centripetal force. It's the net force pointing to the center right there, right? So that's equal to mv squared over r. I'm going to quickly rewrite Fn cos theta over here one more time. Some of you know why here. Oh, it's not divided by anything. Because what I want to do is divide. That will get rid of the Fn's, the m's, and you'll get tan theta equals v squared over rg. And that's important because you can do the inverse tan, and that will give us what theta is. Now you're probably all thinking, well, that's not what the problem's asking. The problem is asking if mu s is 0.35, what is the range of speeds the car can safely make the curve? So they want to know v min and v max. So I'm going to remember what theta, well, whatever, I don't care what theta is. We have what theta is. We'll just say you guys did the math on that. Let me clear the screen here and rewrite this. Now, the range, your picture looks almost the same, where you have Fn and you have Fn in the x and Fn in the y. Let's see here. But now you have friction, and why friction is tricky here, or sticky situation, pun intended. Oh boy, that was horrible. You're going to have FF in that direction if you're going too fast, right? Because if you go too fast, you're going to fly off up that way. And you're also, for the too slow case, friction will be in that direction. So those are, you're going to have to use this one to find Vmax, and this one to find Vmin. And what I'll do is I'll just do Vmax real quick, and then I'll show you how to change it to Vmin. So again, we're going to do the sum of the forces in the x and the y directions. Doesn't matter which one you do first. Fn in the x is the same as the last one. It's Fn sine of theta. Gives you Fn in the x. But now you're also going to have Ff in the x, also in the y, but we're just going to worry about the x in this case, which is helping, so it's plus mu Fn. And if this is theta here that we just found, which is important, that's why we had to do that part, if this is theta, this is also theta, which means Ff in the x is actually the cosine for this one. And that is equal to the net force to the center, so it's mv squared over r. Now in the y, so that's the x direction. Whoops, get out of there. Get out of there. Now we go in the y direction. You know that Fn cos theta, which is up, has to be balancing FF in the Y, which is down, and FG. So I'm going to say minus mu Fn sine theta. That's this term right here. And I could say minus mg, but I'm going to add that to the other side. And some of you know why, because the next step is going to be to divide. All the fn's go, the m's go, and you get sine theta plus mu cos theta divided by cos theta minus mu sine theta equals v squared over rg. Now this v is going to be v max, and you can solve for it. You're going to bring rg over to this side, so it's not there anymore, and then you're going to square root the whole thing, and that'll get rid of that. Now if you want to get v min, now the thing that's going to change, and I don't know if I can change colors here. Yeah, I can. Cool. Thank you. What's going to change is this is not going to be along here anymore. It's going to be up in this direction. So you're going to have friction force in the x that's to the left and friction force in the y, which is up. That's different than down and to the right. Up and to the left is basically the opposite sign for the friction forces. So this and this will both be the opposite. So this turns into plus, this turns into minus. So when we do the math here, we'll change this to minus and this to plus, and we'll call it v min. I hope this is a lot easier the fourth or fifth time I've done this. I know the first time we went through it, you guys were probably a little nervous. Well, you're probably still nervous, but I hope this makes more sense now.